Hello, my name is Monique and I'm going to introduce you to our 4.6 chemistry activity. The topic is Do Yourself How to Be a UPAC Member? What is the UPAC? The UPAC is an International Union of Pure and Applied Chemistry. What do they do in this International Union of Pure and Applied Chemistry? They set symbols, names, and units for almost everything. And what importance of having defined rules to name hydrocarbons? The importance is because it doesn't matter which language you speak or in which country you live, the scientific language is the same in every place. So you can know it even though you speak English, Spanish, or if you live in Iceland.
Are organic chemical compounds that consist entirely of hydrogen and carbon atoms and range from simple molecules. The main classification of hydrogens include alkanes, alkenes, alkynes, and aromatics. This is an example of the hydrocarbon. You can see carbon-carbon and hydrogen around.
Alkanes is a type of hydrocarbon that is formed only by single bonds. Carbon has the ability to form 4 bonds, and hydrogen forms 1 single bond attached to a carbon bond. The rules for naming alkanes. The first one is to count the numbers of carbon atoms in the longest continuous chain. The chain is named the parent chain. Then the step number 2 is to number each carbon in the parent chain. And you have to locate it closer to a substituent group. Then the step number 3 is to name each alkyl group substituent. That is like if it is 1, it is met, and then if it is 2, it is set, and like that continuously. Then the step number 4. In the same alkyl group appears more than 1 as a branch of the parent structures. We have to use a prefix that is D for 2, 3 for 3, tetra for 4, and so on. Before it names to indicate how many times it appears. Then we have to use the number of the carbon to which it is attached to indicate its position. Then the step number 5 is when different alkyl groups are attached to the same parent structure. Place their names in alphabetical order. And you don't have to consider the prefixes D, 3, and so on when determining the alphabetical order. Then the step number 6 is to write the entire name using hyphens to separate numbers from words and commas to separate numbers. So okay, we have to start with the step number 1, which is to identify the parent chain, that it will be the one that has more carbon atoms. So we have this one that has 6, so it will be an hexane. Then the step number 2 is to number the carbon atoms in the parent chain, and we have to name it starting from the one that is closer to the substituent. So this one will be number 1, 2, 3, 4, 5, and 6. Then the step number 3 we have that is to name the alkyl groups, and this one because it has 1 will be a methyl, and this one because it has 2 it will be an ethyl. Then, because we don't repeat the alkyl groups, we have to put the entire name. It has to be for alphabetical order. So we have ethyl that starts with E and methyl that starts with M. So we are going to start with ethyl. So it is located in carbon 3. So it will be 3 ethyl, then 2 methyl, and then hexane. In this example, first we have to locate the parent chain, and in this case it could be in many forms like 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, or 1, 2, 3, 4, and 5. So it doesn't matter where you put it because it will be the same. So I'm going to put them like this. Then we have to number the carbon atoms, so this one will be 1, 2, 3, 4, and 5. Then we have to identify the alkyl groups. That this one, because it is 1, it's methyl, and as you can see, it repeats 3 times. So we are going to use the prefix 3. So in the name, it will be 2, 3, 4, 3-methyl pentane.
In this part of the video, I'm going to show you how to draw a structural formulas with this example. 2-methyl, 3-propyl hexane. The first thing we need to do is to draw the parent chain, that is hexane. Here we have the 6 hydrocarbons. 1, 2, 3, 4, 5, and 6. Then we need to identify the branches. 2-methyl and 3-propyl. So that's how you draw a structural formula.
Well, this is another example that is 4-ethyl, 2-methyl butane. We have here 1, 2, 3, 4 carbon atoms. That's why it's called containing. Then, in the carbon number 4, 1, 2, 3, 4, we have an ethyl. Then, in the carbon number 2, 1, 2, we have a methyl. Here.
Alkenes are unsaturated hydrocarbons that contain one or more double bonds between the carbon atoms in the chain. In alkenes, the parent chain is always the one containing the double bond, whether or not it is the longest chain of carbon atoms. The position of the double bond determines how the chain is numbered. Some unsaturated hydrocarbons contain more than one double bond. The number of double bonds in such molecules is shown by using a prefix such as D, tri, tetra, and so on, before the suffix "-in". The position of the bonds are numbered in a way that gives the lowest set of numbers.
Teach you how to draw alkenes. You draw alkenes using the same method you learned for drawing alkenes. There is only one difference. You have to place the double bond in the main chain. I'm going to show you an example now. First, you need to see the parent chain that it contains the double bond. And we are going to count from where the double bond is near to the chain. So we are going to count like this: 1, 2, 3, 4, 5. So this is a pentene. So this branch is on the number 2, and this is called an ethyl. So we are going to count to ethyl, but we also need to count where is the double bond. So we are going to put 1 to ethyl, 1 because it's a double bond, pentene because we have 1, 2, 3, 4, and 5 carbon atoms.